In a three-term controller, there are three settings, P, I, and D. Today I'm going to focus on the P part. The advantage is that it is the main form of control, and the disadvantage is that it gives an offset. Okay, so why do I say it's the main form of control? Well, you and I use it every day of our lives. Whether you're pushing the accelerator of your motor vehicle down a little bit or a lot, or whether you're pushing your brake pedal down a little bit or a lot, whether you're kicking a soccer ball softly or whether you're kicking it hard, that's always going to be proportional control. That is the main form of control that we can get. The gain setting determines how much more the output is going to change for a change in the process variable. Now I've got a controller on the screen in front of you, and the red pen is the process variable. This is the measurement that we take from out in the field. The blue pen is the output from my controller. My controller is in automatic, and the set point has been set to a value of 200. So what I'm going to do is I'm going to change the set point to 350. Let's go and change the set point to 350, and you can see that the blue pen, which is the signal to the control valve, or whatever the case would be, is going to change, and my process variable is going to change. Now let's go and pause it over there, because I would like to capture this screen for you. I'm just going to go get my screen capture, and let's go and grab it quickly. I'm going to grab it from that side to that side and go and paste it on the screen in front of us, possibly sitting at about that point over there. That should do the trick. Great. I've taken the set point back to 200, and as you can see, when we did the previous test, I had a gain setting of 1. So a 10% change in the process variable would have affected a 10% change in the output of the system. Let's go and change that gain setting to 2. So I'm going to have twice the response. Now, if I go and take my set point and I take it to the same value of 350, you're going to see how the blue pen moves so much more, the output to the final control element, and then the red pen, the process variable, is going to follow suit. Now that's enough. I'm going to go pause it, and let's quickly go and capture the image so that I can put it next to the one that we've already got. Just going to capture it from there down to about there. In fact, I'm just going to take that little thing away and try it again. I'm going to just go and capture it from there to the other one. I have something interfering on the screen. That looks good. Let's just minimize that and paste the image down next to the other one. So we've got two identical images with different gain settings. This now gets us to the disadvantage of P control. I'm going to use a red pen. On the left-hand side, with the gain setting of 1, look at the small amount of movement that we have with the blue pen, which is the signal going to the final control element. On the right-hand side, you can see that the blue pen worked so much harder. We gave it a bigger signal. And then the big disadvantage that I said to you, gain control is going to give us an offset. Look at this. My set point is sitting at 350, but the process variable is way below that. It's at a lower value, and any difference between the two is known as an offset. On the right-hand side, a bigger gain has resulted in a smaller offset, but the offset does not disappear. So in a nutshell, that is P control for you. It is the main form of control, but it always leaves us with an offset. Thank you so much.